Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, arc length and area of a sector of a circle. So this is very similar to just when we found arc length. The sector, remember, is going to be that piece of an area of a circle. So it's going to be just like we did when we found the arc length. When we just found the arc length, we found that the ratio of how much we use to the whole circle. We're going to do that for the circumference for the arc length, and the same thing for the area. To find the area of the sector. So what I'm doing here is I'm going to go ahead and find the arc length again, because we're trying to find both of them. And notice we are leaving it with exact answers, so we want to leave the pi alone. Don't do anything with it. Just leave it by itself. All right, so one thing to notice here, though, we're finding the measure of AOB, they gave us the measure of AOB, which is 150. We're actually looking for the other side. So just keep that in mind here. All right, so we want to find the arc length of ADB. That's this major arc here because it's over half the circle. So this side here is 150. Since this is all 360, if we go all the way around, if that's 150, that makes this side 210. So that's the angle we're actually going to use, is that larger angle on the outside of the angle there. So let's find the actual full circumference of our circle. So circumference equals 2 pi r. So in this case, our r is 9 feet, right? So we have 2 pi times 9. So our circumference is 18 pi. So the fact that we're not putting the pi in there actually makes it a lot nicer. We don't have to worry about rounding or anything like that. Okay. Now I need to figure out how much of my circle I'm actually using. So I'm using 210 degrees out of the 360 possible. So I just need to reduce that, and that'll give me the proportion of the circumference that I'm actually dealing with. So it should be a little more than half, okay, because we're at 210, half would be 180. So if we go ahead and reduce this, knock off the zeros there, divide by 10, and these look like they both did, divide by 3, I think is our best bet. So we have 7 over 12. So I'm using 7/12 of the circle, which according to my check of over half is accurate, because 6/12 would be half, so it's a little bit past that halfway mark. So my circumference is 18 pi feet, right? We're using feet this time. So, but I don't want the entire thing. I only want 7/12 of that 18 pi feet. Okay. So my arc length is just going to be reducing those two things. So do a little bit of reduction here before we start. Divide both of those by 6. Right? So we got 2 and 3, and that leaves me with 21 over 2 pi feet, or if you want the mixed number there, that would be 10 and a half, or if you want the decimal, 10.5 pi feet. Okay. And just double checking again, I'm looking for a little more than half, which would be 9 pi. I have 10.5 pi, so that does look like it would be accurate. So that's the arc length. To find the area of the sector, it's almost the same thing, but I don't want to start with the circumference. I want to start with the area of my circle, which is pi r squared. So here, when I find pi r squared, it's pi times 9 squared, which is 81 pi. But the proportion of the circle I'm using is the same between the arc length and the area encapsulated by it. So it's still going to be 7/12, so I want 7/12 of 81 pi. So this one is a little bit trickier, and I can reduce a little bit. So let's go ahead and divide by 3. That's my only option here. So that leaves me with 4. This leaves me with 27. So go ahead and jump to our calculators. So 27 times 7, we get 189 over 4 pi. Okay, and notice this is area, so this is square feet when we go and figure this one out. Let's go ahead and get a decimal for that, though, just to make it a little bit nicer. So 47.25 pi square feet is the area of that shaded region. Now notice I could get a decimal here because I knew since it divided by 4 it would terminate, it would be an exact answer like I could over here since it was 0.5. But if you get a non-terminating one, if we're dividing by 3 or 6 or something like that, divide by 7, you want to leave it in fractional form, whether it's a improper fraction like this one, or if it's a proper fraction and you say like 47 and 1/4 is fine, but make sure you don't get a decimal because you have to round those, which is not going to work. It says it wants exact answer, so no rounding.